So in this video, I'm going to show you how to prepare the Softrock samples. First preparing the sample, then the Perspex tube, and then using the resin. Throughout all of these stages, I recommend wearing a pair of gloves because the resin is an irritant and you don't want to get it on your hands or your skin. So in the next steps, I'll show you how to do everything involved in preparing the samples. So in this video, I'm going to show you how to prepare a chalk sample for the small chamber arrangement in the frame. I'm showing you how to fit the samples in the Perspex chamber into the frame, but in this video I'm going to show you how to actually prepare a sample. The process is quite simple. In this case, these are saturated samples, so I've first saturated them for around 10 days under a head of water. We don't have a vacuum here for these size of samples, hence I've done it in this manner. Once the sample is saturated, I then tape it inside a bag, and I'll explain why I do that during doing it. And then we use an epoxy resin, a 2-part epoxy resin, which helps to keep the sample restrained during your test. And that's inside the small Perspex chamber, which you may have seen in some of the other videos. So I'm going to explain how to do the taping and the bag at the moment, and then we'll do the resin afterwards. So first, I'm going to take sample C out of the water, just let it drip off into the water so there's not too much excess water. And then immediately I'm going to grab a bag, one of these large plastic bags which you can get from any hardware store or the concrete lab at the university. So open the bag, and then you want to place your sample inside the bag, making sure that the bottom is nice and flat and that there's not lots of excess material on the bottom, because obviously this will be resting on the plastic pucks. We'll get to that. And then when your sample is in the center of the bag, you can then lift the bag up, and then we will take our electrical tape, and I'll show you how we tape it up. The reason that we tape the samples up is to help restrain them during the tests. It also helps to prevent the ingress of the epoxy resin and allows us to reuse the Perspex tubes. It's also particularly useful when the samples are saturated, as it allows you to keep the sample saturated throughout the test and afterwards, depending on what you're doing. And in the case of dry samples, it also prevents the ingress of resin into the sample pore space. In the Softrocks, the pore space is particularly large, so you can quickly damage and ruin your sample. Technically, for a saturated sample, this should not be an issue, as the resin should just repel off of the water if the sample is fully saturated. Also, the fact that the sample is fully saturated means that there's no space in the pores for any additional fluid. However, I've just taken this method over from dry samples to the saturated samples as well, because it's allowing me to basically keep the sample saturated at all times. So I'm going to do the tape up process now, and I'll explain some tips to doing so. So first, make sure the sample is nice and at the bottom of the bag, as I mentioned before. Then take your tape. This is a little bit difficult with the gloves on to find the end, however it's all good. Then place the tape at the very bottom of the sample, making sure that there's no excess bag under there, as I'm doing now. Once you've placed that tape, you can then just begin to start going around, pulling the tape nice and tightly as you go, and working your way up, not overlapping too much on the sample as it's not necessary. In the areas where you have bigger bunches of the bag, just pull it nice and tight there. If you have pieces which are particularly, yep, there we go, nice and tight, all the way up to the top. Make sure as you get to the top, continue to keep the tape nice and tight, and you end the tape right at the top of the sample, because the resin is going all the way to the top, and we want to do a good job at restraining the sample at all depths. And that's the taping process finished. You can see the base of the sample is nice and flat, so when we place it in the puck in the small chamber, when it's assembled, the sample will be nice and level because these have been cut with a large circular saw, so they're nice and parallel. The sample is nicely restrained with the tape. When we place the epoxy resin, which I'll explain how to do in a moment, we'll be able to place it inside the bag. So once you've done this, the next step is to place the sample inside its tube. The first step of the tube is to place the bag inside it. As you can see here, we have a bag inside, and the reason we use the bag inside is to protect the perspex chamber. This does introduce a bit of an issue in that there is basically no friction against the side of the perspex tube, so when you're doing tensile tests, your sample will tend to pull up. However, I developed a small 3D printed component which allows you to mitigate these effects under tensile loads. You place your sample in, lower it in gently, position it in the center, and then from here you can then go ahead and place the resin in. The resin has to be prepared, which I've not done yet. I'll explain how to do that in another video. But the resin will fall between the bag sealing the sample and the bag that seals the perspex tube. We have a large funnel, and the funnel goes down the center of these two bags, and as you fill the resin, it should fill around the sample and restrain it as we mentioned. I'll show you that in the next video and we'll go from there. Just remember at this time, if your sample is saturated, it's useful to then fill a small head of water above the sample, and this will help to keep it saturated and prevent any drying of the sample at the top area. Also remember that the bag is fully sealed, so no water can get out from the bottom. But be careful with these bags as they're easily damaged. So if you damage the base of the bag again, it will begin to leak, and that poses some problems for the multi-axis frame inside the CT scanner. So as you can see, overnight I've left the samples under their head of water, thanks to the plastic bag that we put them in. Today what I'm going to do is place them in the resin. I didn't get around to doing this last night. So in each of the perspex chambers, I'm going to place the outside bag in here, and then I'm going to place the sample in, locate it in the middle, level it, and then begin filling the resin. I'll explain how to mix the resin and pour it into the sides of the sample, and then we'll go from there. Any sort of hints and tips I will give you along the way. So to calculate the resin volume that you need, you know the size of your sample, so you know your diameter and your height, so you can get your volume. And for your perspex chambers, you also know the diameter and you'll know the volume because the height of the sample will be the same in the tube. So you can calculate your volume from that. And then we can go ahead and mix the epoxy. So to prepare the resin itself, this is a glass cast 10-50 Easy Composites resin. On the packet there is a mix ratio, and it is 100-50. So 100 resin and 50 hardener. For example, if you have 0.6 kilograms of total resin required, that would mean that you would need to have 0.4 kilograms of resin and 0.2 kilograms of hardener. It's particularly important to get the mix proportions right, particularly in the case if you don't add enough hardener. What can happen is the resin doesn't cure correctly. If the resin doesn't cure, your sample will not be well restrained, and you'll notice that the epoxy resin just takes on a very thick fluid-like nature. So just be mindful of that when you're preparing the mix. Make sure you get it right, because there's not really any going back. If it turns out that you didn't get enough hardener in and the resin has not cured properly, then you can decant the sample and start again, but it's quite a difficult process and it's very messy. So just try and get it right at this stage. So the first thing I'm going to do before I mix the resin is put the samples into the tubes. As I said, we have this outer bag and then the bag inside the sample, and this will sit in here. And then I'm going to center it and make sure that it's nice and level, so that when we go to put the resin in, we get a nice band of resin which is even all the way around the sample. So now that the samples are in place, what I'm going to do is just check that they're nice and level. I have a small pocket level here. I'll just go in and have a look, and I can see that they are level. You will probably not be able to see it on the video, but that's just thanks to them being cut nice and flat. The benefit of keeping the samples nice and flat is that if you're doing a long deformation analysis test, or you're installing a pile to a great depth, you're obviously going to keep the sample nice and straight, so that you're going to have no variation in the effect of boundaries with depth. Obviously you may have densification of the pile at the tip and so on, but in terms of the pile veering off towards the edge of the sample, that will not happen because everything is nice and straight. So just bear that in mind when you're preparing the samples. The other thing, as I mentioned before, is just to get them nice and centered so that you get a good band of resin around the samples so that the sample is well restrained in every area. So to ensure that the samples are actually in the center, I like to just go around with a screwdriver or something similar and make sure that there's an even distance around the sample and the Perspex wall. So I'm going to go ahead now and mix up the resin. I've calculated on my computer how much volume we require for each sample, and I'll mix that up in a batch for the 3 samples we have here. And then I will mix it using just a spatula is fine. You can see the pot here that I use. Obviously any excess just dries with time. You can actually see the tip of the funnel has been left in there. So we can go ahead and mix now. So I've calculated the amount of resin that we need to make for these 3 samples. I'm considering the volume around the sample in the Perspex tube. If we also consider the specific gravity of the mixed epoxy resin, we can calculate the portions of mass required when we're working it out. So in this case, we need around 2,734 grams, and I will now work out the portions which are resin and hardener, add them together, mix them up, and then I'll show you the pouring process. So when mixing the resin, just place the bucket that you're using to mix it in on top of the scale, zero the scale, so you can work out the portions as you go along. So as I mentioned before, make sure to get a pair of gloves on before you start working with this stuff. It could be bad for your skin, so just keep a pair of gloves on when you're working with it. The first step before we start pouring it is to give it a good mix. So I'll give it a good shake, and then I'll use a spatula or something inside to try and move any lumped pieces of resin, and I'll show you that now. So just giving it a good mix all the way to the bottom to catch any of the hard lumps that have formed. When the resin's left, it tends to not set, but just settle at the bottom, so remixing it helps. Once you're happy that this is all mixed, you can go ahead and do the same thing with the hardener, although you can just shake the tub for that, and that should be sufficient. I'll just make sure there's no excess there. Take in mind when you're using this stuff that it is very messy, so just clean all your utensils up as you go along. It helps to keep things nice and tidy in the lab. Save you a lot of faff later on. So now we have the hardener as well. So I'll give this a quick shake. You can see it's a lot less viscous. It's much easier to shake up. So you can see that. So shake it up now. So now I'm going to pour the resin and the hardener portions. So we need a total of 2.828 kilograms. And the resin portion, which I'll pour first, is 1.885 kilograms. So I'll just pour that into the tub. That's going to be essentially the rest of this tub, I think. And there we are. So that's 1.89 kilograms. It's not far off. Small amounts of difference will not be a big issue, but significant differences in the mix proportions will cause an issue. I'll obviously just put a very slight bit more of hardener in here to compensate for the increased resin. So we need 942 grams of hardener. So what I'll do actually is just turn the scale off so it's easier to calculate. So I've turned the scale on and off, and that just allows me to zero it, and it'll make it easier to work out the hardener portion. So I'm now adding the hardener. This is around 940, and there we go. So that's the portions of the hardener and the resin mixed into the pot. Now I'm going to mix it together, make sure the hardener and resin are well mixed in, and then I'm going to go and pour the samples, and I'll explain how to do that in a moment. So when you're mixing the samples, take it off the scale first, back over to the lab bench, and just mix it in. Spend some time doing this. I'm not going to stay on the video because it makes it quite noisy. But just keep mixing it up until you're satisfied that everything is mixed in. And then we'll go to the next stage. So we're now ready to pour the resin into the samples. I'm going to explain it for one or two, and then just carry on. So the first one, I've made this small funnel which goes down to the base of the sample or into below the sample. So if you just place that in now, sometimes it's useful to just take something to bend the end. As the resin dries around it, it seems to expand outwards a bit. So I just usually put it on the floor and push it down. You can see that now that that's been pushed down, it's a lot of a narrower end, so we can get it between the sample and the Perspex. So once that's in, take your resin and just begin pouring. Be careful not to pour too much, because you can quite easily overfill your sample. So add in up to the top of the funnel and let it pour out and work its way around your sample, and then you can begin to see how much more you may need. So one thing you'll find when the resin goes into the bag is that the outer bag is sometimes imperfect. So what you can do then is take a screwdriver and just work the resin around the sample to make sure that you've got good contact with the wall on both sides. Adding a little bit more. And that should be almost enough to get the sample to the top. The other benefit of using a screwdriver or a spatula to move the bag out is that you fill any voids, and you can work out whether you need any more resin in there. So with these samples I'm moving, I will have to re-level them, but it's just so I can show you on the video where the resin is going. As you can see, the resin is between the inner bag for the sample and the outer bag protecting the Perspex tube. So you can see that the resin is almost at the level of the top of the sample. So at this point, I'm just going to take the screwdriver, which we've been using, and just gently move the resin around the bag. Be careful not to pinch the bag, because you can quite easily tear it, and when you tear it, the resin will rest against the Perspex, and it will make it a lot more difficult to move your sample around once it's cured. Obviously we'll need to rise the samples up to the top to put the plastic pucks in and the base coupler. So just make sure to avoid popping the bag. Done this a couple of times, makes things very difficult, time consuming. So I'm just going to add a little bit more resin now that I've been round the sample and removed some of the voids. So taking the funnel again, placing it in, using a small amount. It's okay if the resin goes a little bit above the rock line, because you've got that inner bag, it's going to protect the sample anyway, so I wouldn't worry about that too much. Just don't put excessive amounts in, because it's just a waste, and it will make the area around the top of the sample smaller and more difficult to install your pile or your shell foundation, whatever you're doing. So I'm pretty happy with this one. I'll just show you now. So you can see the epoxy is slightly above the sample. It will move down ever so slightly. There's not a lot of volume change or settlement as this resin cures. However, just with the bag, if I go back in and move these small recesses here outwards, they're obviously going to take some of the volume of the resin. So otherwise the sample's good. You can see it's nice and centered. It was also nice and level. So we can leave this sample now to cure for around 5 days. I'll come back periodically over the next couple of hours just to check the level of the resin. If it drops down too much, goes below the sample, add a little bit more. But usually if there's significant volume changes, that's indicating that there's potentially been something up with your mix proportions. So just bear that in mind. Otherwise, I'm happy with the sample, and I'm going to move on to the next two. And there we have 3 prepared samples. Obviously the resin is a little bit higher in this one, but again, it's not the end of the world. In all cases, the samples are level. We've checked them. Now what I'm going to do, I'm going to leave them for about 10 or 15 minutes, come back and see how they look. If the resin level has dropped significantly, I'll add a little bit more. We have a small bit of excess resin there. Otherwise, we're good to go. So I'll come back a little bit later, and as you can see, the samples are all still fine. The resin level is sufficient, it's not dropped down too much. So I'm happy that these are good to go. You can see all the air bubbles that were originally there have mostly disappeared, and now the curing process will begin.